So in this final example, there's a lot more to think about and there's a lot more to pull together. So we're going to just pull it apart and go one step at a time and go nice and steady on this. What we have is, in this diagram, AB is the diameter of a circle. So, I mean, that tells us actually straight away that there's a little right angle up here. We may or may not need to use this, but it's worth just paying attention to those little things. Sometimes those circle theorems are essential to answering a question, so it's worth just pulling that in. And then we've got our radius r and our angle theta. They're marked up on the diagram. And then we're given that the area of AOC is 3 times that of the shaded segment. So that means that this area is 3 times the size of this really small yellow shaded area. And then we've got to show that question. So our ultimate goal is to land on this thing somehow. And it's really not clear how we're going to end up there. So what we'll do is we'll just pull this to pieces. There are 2 different areas that have been mentioned in the question. One is just a triangle area, and one is the area of a segment. And we know how to find both of those things out. They're not a big problem. The area of the segment I can just do directly because I know r and I know theta. So this area is half r squared theta minus sine theta. Okay, and we're done. We can reorganize that and tidy it up some point later. Maybe there'll be some cancelling out. I don't really know, but I do know that's the area of the segment. The triangle, so AOC, it's a little bit more awkward because although I know r, I don't actually know this angle, except that I do know this angle because this is the diameter, so it's a straight line, and a straight line 180 degrees, but we're working in radians, so it's an angle of pi radians. So this angle is actually pi minus theta. Okay, just like we do 180 minus our angle. So the area of AOC, this triangle, is half AB sine C. Well, A and B are both r, so it's half r squared sine, and then our angle is pi minus theta. Now at this point it would be really helpful, because in the question I only have sine theta, I don't have any kind of pi in there. It'd be really helpful if I could reorganize this somehow. So let's just think about our cast diagram. Sine of pi minus theta, remember that sine is the height of these triangles. Well, where else is sine the same? Really helpfully, it's exactly the same over here where my angle is just theta. Or we could remind ourselves on the graphs exactly what's going on here. So if I have my sine graph, here's pi minus theta, here's theta, same height. So actually, sine of pi minus theta is sine of theta. That they are exactly the same. Okay, and there was a video earlier on in the series talking in a bit more detail about these symmetries and these related values. So I can rewrite this as half r squared sine theta. Final step, I need to use this fact that AOC is 3 times the size of the shaded segment. So that means that the area of AOC, half r squared sine theta, is equal to 3 lots of half r squared theta minus sine theta. Okay, they're 3 times the size. What I can now do is I can divide both the left and right hand sides by half r squared theta. R is clearly not 0. I can divide through by r squared. So that leaves us with sine theta equals 3 lots of theta minus sine theta. And hopefully it's quite clear what we do now. We just expand these brackets and subtract to sine theta from each side. So this leads us to our 3 theta minus 4 sine theta equals 0. Okay, all I've done is expanded out and moved that spare sine theta across so it equals to 0. So once we unpick that, it's not super complicated, but we've had to use the area of segment, area of a triangle, and those symmetries in the sine graph, and a little bit of manipulating algebra. So it's easy to get a bit muddled up in there. As I've said in a number of my other examples, take it one step at a time and get down on paper all of the information you have before kind of pausing and thinking about it. Get it down on paper, and then it's not so difficult to see what the next step might